Hello and welcome to Summit. My name is Elliot and I'm here to tell you about how short path distillation technology is changing and what the new standards are and where things are going. Our first question that most people ask us is what happened to parts 3 and 4 in our last series? One of the things that happened when we were filming and preparing for the other two parts was the technology changed so fast that there was no point in posting it. We wanted to advance so fast and with so much progression that the older videos would probably have kept us behind if we stuck to those old SOPs. So with the technology changing, first thing we're going to go over is what products Summit sells and what products we've worked with and which ones we're going to discontinue and which ones we're going to continue to work with. The first ones we're going to talk about is SPD1 and SPD2 Legacy. These two heads are the easiest to operate, the most affordable to jump into, especially with a hosed cold trap, and they're going to give you the best performance in the market for these types of designs. The cornerstone of our new technology for the fraction collectors came off of SPD2 and SPD3 Thermal Plus series. These dual wall heads performed so well that as we started doing research and design into the SPD4 MPD, we came up with a product called a fraction collector. So all of our heads are being upgraded to this new technology, and SPD2 thermal and SPD3 thermal are being discontinued. What does that actually mean? These heads perform just like an original design, but they're a lot more they have a lot more heat retention due to the dual vacuum jackets. We aren't ditching the design or the geometry. What we're doing is we're upgrading it to the FC series, which comes both in 34 and 45 size. What this is a fraction collector installed at the top of the head. So even though we retain the same geometry, the same design, and the same functionality of the original SPD Thermal Plus, we now have shortened run times, higher quality product, brighter colors, much lower residency time, up to about half, because none of the stuff in the head is now rejecting back down. It's being collected in the cup and then it is drained right out of the system. So we have not only the highest potency, highest speeds, but best product quality coming out of this series head. So that's going to sum up what heads are being discontinued and how we're moving on to the fraction collector series for all products moving forward. That's the first thing. So a lot of people have been asking us about distribution adapters. We're going to go over some stuff that will help you guys understand the differences between them. We have a legacy monocow, which is a bulb monocow. Then we have a new series monocow, which is an extended glass tube, which helps separate any impurities that are in line. Then we have a high efficiency monocow, a very unique product that we've been bringing to market, where there is a coil condenser in there that takes off a lot of that condensate out of the vapor stream. So from there we moved on to laminar path, and we're going to show you that here in a second. One thing we wanted to talk about was everyone always said, you know, why do we avoid bellows? Well, we wanted to talk about that and explain why we believe bellows should never be anywhere in the short path system, directly near the short path. The dislike of using this product is that when you have a very fast pass or you're moving a lot of molecules downstream, they line the surface. And the easy way out is to just try to attach a bellow straight to a short path head and get a higher CFM. The straight talk is for a 2 liter or 5 liter system, even some larger ones, between a 1/4 inch and a 3/8 inch hose, you get about 10 CFM of pull. That's quite considerable, and it does work. Everyone's been doing it. A lot of people have been very successful. If you are going to do an open bore pathway like a bellows, I believe there's a different way to approach this problem. Number one, we want to ditch these as best as possible and keep them away from the short path. That's the first thing. The second thing is we also have an issue when you use high CFM throughput in the short path. It'll rip right past the cold trap. So the benefit of using a basic hose system with an SPD1 or SPD2 actually limits how much these saturated molecules creep up the cold trap and into your pump and just damage and destroy your vacuum depth. So with that, we also want to talk about the grease updates. We originally had access to basic 150 Celsius silicone grease. We chose not to use grease and just do dry joints because we didn't know of anything in the market that was better. We stumbled onto Curatives, and Curatives solved everyone's problems. We started distributing the product, and recently there's been branding changes, and somehow the product quality has changed. So we moved on to a newer product called Apiazon, which is an extremely dense grease, and it will hold even under diffusion pump vacuum rates. Okay, so over here we're going to start talking about the new short path and how it operates. So first things first, we got a nice tight thermometer adapter and a thermal well right in here just for taking temperatures if you need to. Some of the really cool, interesting setups that we offer now is direct pipe connections. And how this specific short path works is you have your boiling flask, you have, for instance, here's an SPD5 FC thermal head, and now it comes down to your laminar path monocal. And we no longer have to actually remove the monocal off the short path distribution, the short path head. The actual distribution adapter itself only requires a pull flask. So people always ask, how did you solve that problem of contaminating all of the product without having to change the flask and isolate all the glass, you know, removing the dirty glass off the system and putting clean glass on it? Well, the design that I came up with is the vapor will pull right past this point, and the discharge from the distillate will flow straight down the center and touch just some parts of the glass, not much. And all this is moving because it's very hot. All this other vapor creates this kind of a line that you can see when it starts to build up, and it just drains off. Now, everyone always asks, well, why did you put a coil there and just not let it come off? Well, the coil actually serves a really important purpose, which solves a problem for full-bore, hard pipe connection systems. First things first, we're able to now separate different layers of vapor from the discharge of the head. The first vapor is going to get converted very quickly down to a liquid, a distillate, and that's what's going to come off this head. If we increase the temperature of this head and decrease this coil, we create a temperature matrix, and how that affects molecules, how it pulls in a molecular vacuum. So the distillate will flow down while these other hotter, more excited gases will bounce around and bypass it. Now this super chilled coil will will condense all that vapor that's dragging to the surface, and it will now drain right through the trap and out. So that's the first thing that we wanted to go over, is how this new system works with being able to shut off vacuum and just pull a flask and replace it and not have to worry about anything else in the system. Next, everyone likes this idea. It works great, but we want to really show you the heart of this hardline connection technology, and that's with this trap. So we're going to zoom in here, and I'm going to give you a little bit of an example, a little bit of an explanation of what's going on here that prevents pump contamination and actually allows a deeper vacuum. This whole system operates similar to having 3 traps. Yes, this would be a smaller one. It wouldn't be much, but it would give you a lot of heat removal energy. Like the energy that's being removed from the vapor stream, it is being subcooled so fast that it wouldn't heat up your trap as much, especially if you have a negative 100 immersion chiller. So not only does this portion take down the massive bulk of the energy, now if you look very carefully inside of here, the dry ice bung is extended beyond the cone with an upside down cup. And the only thing that's touching the cup is the inlet port right here. So all the energy that is usually being ripped off the top of the trap where you see condensate drag up, that energy, that cooling power, is now chilling this inner cup. And the unique portion about this is it turbulates the vapor. So when it enters this cold section, it's slowing down so fast when it's hitting the glass that it almost sort of spins. It just kind of like hits it, but it stays in there. So when you see that fog coming off your distillate, it's capturing that, turbulating it, and turning it to a drip. This specific shape actually prevents it from crawling, and it prevents the vapor on a throughput system from just ripping right past the trap. Most people's traps are set up not to prevent this type of system to happen. This hasn't ever existed, and I'm bringing this technology to you guys to solve all the problems that occur with full bore type of distillations. So on this type of a setup, as I've been explaining to you, we have a fraction collector. We have this laminar path monocal, which has an adapter right here, as you can see, for the sensor. So now we're able to see exactly what's going on in the short path, right past all of this crazy area where the reading would be up and down, like over and over and over. It would just fluctuate. Right here we have a stable reading of what's coming off right on the tip of the ending of the short path itself right here. So now, as this cold trap does all the work, this is an inverted cup cold trap, it goes to a hard pipe. And this comes in a couple of different variations. Some people like it at the ground, so we have another piece that goes to the ground. In this case, we have a dual pump setup. This is a VFD pump that we have on display. And we have it on a cart. So then people say, well, how are you connecting it? Well, we're using a bellows here, even though our plan is to supply a smooth pipe bellow, not a corrugated metal one. For the point of argument, keeping a bellow at the end of the system to help isolate any vibrations from the pump is actually not as counterproductive as keeping it in the center of the system where you're having the distillation. So it's a moot point of argument, but in my opinion, I would love to see PTFE smooth bore bellows being offered to the market, which is going to be a lot harder to get, even though everyone is asking for them. So it's going to be very soon that we're going to see them. On this type of a setup, we have a vacuum pump sensor that will also give us the reading on our SVG3, both from the short path and the pump, giving you a curve reading so you can actually understand what's going on, if you have a leak or if there's a problem. Okay, so how do we have connectivity between most pumps and traps? Well, the CT1 original cold trap has a DV1, it's a swage lock style, and fully assembled part that helps reduce all the leaks that go through the trap to the pump. In this case, we're going to be upgrading it to the DV2, which is really high-end, leak-free Edwards valves. And how are we doing this, and why is it set up like this? Well, we have a valve right here, and we have a valve right here, and this one may also have a bleeder or a needle valve. The point of this is, when we were doing standard distillations, we saw that traps and pumps would get soaked. So during the initial portions of the distillation, say 150 to 170 Celsius, you would be running a diaphragm pump on a valve here on a gate, and that would pull all your volatiles out. And this is going to prevent anything from getting into your main pump. You're actually going to have a higher performance factor as well, because those solvents never touch the main pump. And you're able to do your swaps and remove maybe the ball with water or alcohol or terps in it that are going to cause you distillation issues. So after that's completed, you would lock off this one valve and open up the other valve, and now your full bore operation with no solvents, a dry pump that's been running, it's hot, it's ready to go, and it's not contaminated. So here is our laminar path setup with the full bore kit. This specific trap, you know, people ask me, what's the difference for distillation? And I say, if you have $500 or $600 to go in for a basic hose cold trap, you're in the door, and you're going to get the job done. If you go down this route, you're talking about almost 3 times the cost for the kit because of all the connections. So there is more of an investment there, and there's also costs with the Edwards valves. So the technology that we're offering for the inverted cup is only on this type of a system, because the amount of flow that you get actually is it's as damaging to a pump typically. You know, you can get a lot of terps, a lot of air, a lot of wet molecules to usually go through a pump and then soak the oil. So the way to avoid that is with this type of modification, which prevents that from occurring. Okay, so Other updates. We believe in April or before April, the actual final version of the Fraction Finder will be available to the market. The first ones that were released were for testing and are in people's hands for mining the data. So we're able to actually tell you what fraction you're on based on the wavelength. You'll be able to identify when you're going into your heads, when you're coming out of the heads, when your potency is going down, and into your tails. The unique part about the Fraction Finder is it's going to tell you if your product wasn't winterized properly. It's going to tell you what's in the vapor stream. If you have volatiles or if you have things coming over, you can actually identify those as well. It's going to tell you overall when you're going to hit your highest peak potency, and then before the head changes color and you can actually notice what's going on, it will start to give you different readings that will tell you that the stream has shifted. There's something else in there, which means your potency is going down. The Fraction Finder is going to be the product on the market, the largest adaptable product to any short path in any manufacturer, and we're going to be the exclusive distributors, and we're going to get them in all the hands of our distributors and all the competitors because we want this product in the customer's hands. So everyone likes the SVG3 Touch, but we also want to do a shameless plug for the SVG3 Touch. The standard SVG3, the SVG3 regular, you have to click through the screens to see where all 3 points of your vacuum are. The Touch is going to be a screen that can be loaded up, a touch screen that will go right, which will clamp right on the system, and that one will also release shortly here, and that's going to give you real-time graphs with logging and with all kinds of different information that will give you an idea of like what's going on real time, not having to click through it. Both the Fraction Finder and the SVG3 Touch are going to be Ethernet compatible and Wi-Fi, which will allow you to be able to basically look at your phone from a different room and see where your wavelengths are at and where your vacuum's at, which is amazing. Okay. I hope a lot of this information has answered a lot of your questions on why I have not posted videos in a long time. Technology that we're not going to be talking about in this video is the Big Bertha, which is also being made as Mini Bertha, the MPD, Modified Path Distillation, where there's two pathways in the system that does different things for refinement, mostly for CBD work and high refinement work. We have an ultra low pass temperature project, 2 heads that are coming out. Part of the Hobbs project is the HB1 and the HB2. The HB2 is going to be an initial non-selective head that pulls very fast on large batches. The HB1 is going to be a low temperature distillation head with some pumps and some of the modifications that we have in our system. We're going to be able to hit very, very low temperatures, roughly 50 degrees lower than you normally would. These products are all going to be released here shortly. They're all in line with the shows, so as the shows come up, please come visit us. We're going to be bringing this specific setup to Seattle Canacon. So if you want to purchase a complete functional system with all the sensors, all the pumps and everything, just let us know. We're bringing a couple of them there. If you're interested in the discontinued SPD2 and SPD3 thermals, they're going to be half off until stock's gone. So we only have about 30 or 40 of these heads left to this day. And hey, they're basically more than half off. They still work great, but we're making room for the new heads. And if we can zoom in here and show you guys kind of what's so cool about this is the new generation of short path technology. This is going to be what all future technology in short path is based off of. This is our laminar hard pipe setup. Both the fraction collector, the inverted cup, and the hard pipe with the valving system. It's a combined product, which is the heart of the fastest, most adaptable, highest potency short path distillation system on the planet. I mean, we have other large scale systems, but for a 5-liter system, compared to all the competition, you'll be running through product faster with the Summit setup, and you'll be getting the highest potency on your first pass. So when you're refining, the system works exponentially well, especially if you hook it up to like a modified DV2 where you're running a diffusion pump. Now you're going to be running into temperatures automatically 20, maybe 30 degrees less than you normally would on a refinement pass, and you're still going through multiple liters an hour, just crushing through it. And there's really nothing else in the market that can give you the type of accuracy that this system can. We don't use bellows anywhere in between our system. There's maybe a small connection at the end, but we focus on a laminar path, hard pipe, and that's going to be the heart of our technology, and it really does stand out as the best system on the market. Thank you.